to this study. This drives the scientists crazy. So this is what is happening, and what's wonderful about that is exactly what's happening in your heart. It has the same force as going on in your heart as this one right here, except the distance from here to here are muscles. Okay, so in the past, the Earth had all of its plates that we walk on, okay, we're at the bottom of the South Pole. And they're moving up like this, according to the scientists. That's how come Africa can be split apart like a puzzle. They're moving apart like this, and they're going up to the top in the future. Now, if that was the case, if these continents were moving up and going beyond the equator, and you can see that they're going these were all at the bottom. They're going above the equator. This one is moving up. You can see it's really moving up. This one is starting to move. It's held up by us. But we're up here too. So if this was true, if these were all moving up in the sphere, these land masses should be around the periphery. It should be around the equator. And you know that. But you know that because of if you think of centrifugal force, and you take water in a bucket and you spin it around, you know how we used to do that? It doesn't come out. Okay, so I took a sphere and I put some dirt in it, or sand, to see if this was right, to see if I could show if this was right, to find out what this does. So what does it do? When the centrifugal force works, it goes right to the middle. So if this is, so how can the force go above? So what I did is I took this shape. I took the two cones. There they are, and there. It's kind of hard to see because it's not too clear, but you see them? See the two cones? Okay, so I left some of the sand in the outside of the cone. I put the other ones on the inside to see if this could be and have an effect on those continents moving up. So here we go. Oops. Well, one end's still there. Didn't get you, did I? Good. Well, that's not going to work. The one that broke off is the one I needed. But if you spin this, the blue will go right around here, and the yellow goes all the way up to the top, which you see showing here. It looks like that when it turns. So this is another reason that maybe that's why the continents are moving up beyond the equator. See how they was all together at one time? And then this one got me. I saw the aurora borealis. And I saw the aurora borealis, and so I took my measurements from here to here, down to the center here, and it's 22.5 degrees.
Where's the aurora borealis? I don't see it.
What's that?
How is this a picture of the aurora borealis?
How'd they get it?
No, how is it a picture of it? Is that
well,
at the top that we're...
Yeah, see the aurora borealis, you only can see at night. So these are night pictures. So the aurora borealis is right there. And it's a circle. See the top of it? What's so interesting is that it starts at one point, gets a little bigger, starts at one point, gets a little bigger, and then it goes into three. And those three are exactly where the triangle fits on this form in the Earth. Those 3 points that are lighting up are right here, and right here. Why are there three? Nobody knows. So if I go back to this one here, okay, this is the aurora borealis. This is the size. Now also there is a light phenomena, at the South Pole. And it's the same size. There they are. And they're moving. Can you see them move? What's so interesting is that they move back and forth. They don't just go one direction, even at the bottom. They'll move this way, then they'll move this way. How come? They're both moving, and they're both the same size, except sometimes the aurora borealis gets bigger at the top than it does at the bottom. The bottom always stays the same, but this guy here gets bigger sometimes. See that? And what's amazing is this circle right here and this circle right here are those two circles. I measured them. And what happens is that the aurora borealis stays within these two circles. It never gets in here. But it gets into what they call an oval, which is an ellipse. This is called the aurora ellipse. And there it goes from the edge here, which is always next to the sun, and then it swirls around here and gets right to that edge there. Here it is again. Shows the two circles and where the aurora borealis goes. Now, this is in the North Pole. And here it is again. You're looking at an angle here because the satellite was over here. But there it is, the same thing with the circle in the middle. But at the bottom, it always stays the same. It always stays the same at the bottom. And things go in the middle. Something happens where the aurora borealis can, let's call it Australia borealis, but it goes into the middle here, but it never goes outside. Look at them all. They're all studies of the South Pole. And it's funny that there's this kind of line that comes in here into the middle where that never happens on the other one. Okay, so what I decided to do is to figure out, does this have anything to do with what I'm finding? So I can maybe use this wire. So what happens is that the energy, which is the aurora borealis that you can't see except at night, comes in the bottom and comes out the top like this. It can't get in the middle, but it can at the bottom. So the aurora borealis would go from the outside all the way to the inside here. So that's here. Then it swings the oval, goes all the way around and hits this outside. And that's how it can do that. No one else explains this, how this could possibly happen. They don't know. And also there's that line. So let's see what else I got on here. Now, how else can you decide whether what is one true, what's another truth? You see, the scientists say that 50% of the time they're right and 50% of the time they're wrong. They don't know which side they're on. Okay, here it is again. And these are the basic three spots that it enters. Now, we can explain this why it's three. That's because all the energy hits around that triangle. For instance, if I take this triangle that I had here, okay, there should be an inside triangle that turns. You see the inside circle? That's because it's coming from these edges. All right, let's see. Here it is again. It shows to me, it looks to me like at the South Pole, North Pole, that the energy is being sucked in. Doesn't that look like it's being sucked in? All right, now here is really neat. Jupiter's auroras aren't lined up. One is just like the South Pole, but this one is at an angle. Look at that angle. At one time, it's not, though. When the satellite goes around more times, this gets off. They don't know why that happens. It's very simple. The reason it gets off is because this is lined up perfect. But at the top, it's not. It's not lined up perfect at the top. It's off to one side. So the aurora borealis at the top goes from here to here, like this. And this one, you can see, is flat on the top. This one is flat. But from my fingertip to fingertip, it's at an angle. This is at an angle, and that's why it's tilted like that. Now, I don't know if this is what's in Jupiter, but I just know that this maybe explains it. There's better that soak up the cosmic rays that are harmful for us. Another thing I looked at. Okay. Now also, what's interesting about this is that the Earth, in relationship to the moon, okay, is the same as the sun. And it's also the same as the core of the Earth. So the scientists are now saying that the core of the Earth and the moon and the sun are all the same size. Now, the sun is huge, you know that, but when you look up at in the sky, it's the same size as the moon. So here's what their new scientists are saying. The scientists, this is right off the internet, this is within 1 year, the Swiss, no, these people are from Sweden. They found out that there is a cube in the middle of the Earth, not a sphere. And the reason they did this is because all the studies that they do with seismic studies that go across like this, like this, like this, they measure the distance, how long it takes to get to that hard core, how long it takes to get through it, and then how long it takes to get to the other side. And they could not figure out, they had this great variety of sizes of the core of the Earth. That's because they're finally realizing that there is a cube in the center. This is right on the internet. Okay. If I take this form, I don't know if you can see the cube in there, but that cube that's in there, that came geometry, not from me, it came from the geometry I showed you, from going from points to planes to points. If I put a circle around that cube, it's the same size as this circle. And this size circle represents the moon and the sun. And the square, the cube that's inside there, is exactly the same size. Now, how do I know this? Because I divided this up into 11. And I'll tell you why I divided it into 11. And I divided this into 3. I used all the same measurements. So if you come up and look at this, and I'll leave it in that glass case, you'll see that there are 3 divisions. Then you'll see that there's 1, 2, 3, 4. It's the top of the cube. And then in the cube, there's 1, 2, 3. And then at the bottom, there's 1, 2, 3, 4. 4 and 3 again is 7. And that cube hits exactly in the middle. Now, I was very upset when I first made this because that cube didn't line up. When I put it down on the table, the cube wasn't in the middle. I was so upset with that. But as soon as I put it into a sphere, it's exactly in the middle. You can come up and look at the equator of this 2 spheres, and it's right in the middle of the cube.
So Frank, one more time, the circle on the top is,
This is the,
will fit into the square in the center?
yeah, this, if I take the square, the cube,
Yeah.
it'll fit into the sphere perfect. And this is the size of the moon, and the size of the Earth, and the size of the core of the Earth. So there's a relationship. 1, 2, 3. Now, who's doing this? It's not me. How can this possibly be? I didn't start out to find out there's a cube, and I had nothing to do with its size.
The dimensions they found of the cube in the Earth on the internet, does that match the dimensions you're
What's that, Robert?
talking about from Sweden?
This cube here,
Yeah.
what about it?
How does that cube, in its dimension, according to the science they're doing in Sweden or wherever, match up with the dimensions you're finding here?
Okay, according to this research here, okay, they think that's a Rubik's cube. And that size isn't in proportion, okay? That size, if you put it around the sphere, it's the size it is, okay? But there's also another group from Berkeley that also found here in Berkeley that also found there was a cube that's smaller than this drawing. So they don't really know. But the geometry doesn't lie. It can't, if this is the case. Now, another thing about it is they think there's a cube in the middle of the Earth. That's not the shape of the middle of the Earth. This is what the middle of the Earth looks like. It doesn't look like that. This is what it is. They are saying that the seismic radiation that they run through the Earth from the top, okay, goes through faster than from the side. This makes sense because this right here is blocking it, goes into the cube, then is blocked on the other side. So this distance here is a lot slower than the cosmic goes through this way. Now you're going to say, well, what do you mean? Why? If that says that's a